In previous videos, I talked about the importance of learning the special triangles for 30, 60, and 45, and the cast rule and the relationship between the different angles that result when you're winding an arm around in a coordinate system. Now, if you understand those concepts, this should be fairly easy. The sine of 210, if you want the exact value, you think of coming around here 210 degrees, which takes you down into quadrant 3. That leaves a 30-degree angle against the x-axis. It also tells us that we're in the third quadrant where the sine is negative. So all we have to do is work out the negative of the sine of 30 degrees, come to our triangle here, opposite over hypotenuse is 1/2, and the value for sine 210 is -1/2. So really all you have to do is figure out how big the angle is against the x-axis. Here's another example, the cos of 330 degrees. If you come around 330 degrees, that will leave a 30-degree angle in this fourth quadrant where the cos is positive. So the cos of 330 will be exactly the same as the cos of 30 degrees. Again, go to your triangle, cos is adjacent over hypotenuse, and that gives us √3/2. I'll just do two more examples like that. Here I'm looking for the tan of 120 degrees. So once again, I rotate around 120 degrees, which leaves a 60-degree angle in the second quadrant. Tan is negative in the second quadrant, so I will have the negative of the tan of 60. Again, I go to my triangle. The tan is opposite over adjacent, and that just gives me -√3. I didn't bother writing the 1 underneath it. One final example, sine of 225 degrees. Come around 225 degrees, that will go 45 degrees past the x-axis into the third quadrant where the sine is negative. So it will be the negative of the sine of 45. So I go to my triangle, sine is 1/√2, and that gives me the value for the sine of 225 degrees. If you understand the cast rule, you don't have to redraw these diagrams in the coordinate systems. The cast rule will give you the positive or negative sign that you need there, and the angle left between the terminal arm and the x-axis will be the acute angle that you use to get your answer.